Hello, Shabab. If you please, we are going to answer some multiple choice questions. If you please send me the answer on the chat because it was your homework. First question. Okay, the diagram shows a cork with a weight attached to the cork floats upright. Okay, as you can see here, there is a cork, there is a weight. Transverse wave traveling across the water from X to Y, to the right. Which way do the waves make the cork moves? In which direction does it move? Is the answer A, right and left, B, up and down, C, only to the right, D, only to the left? Send me on the chat. Yes, thank you. Another answer on the chat, if you please. Okay. Who else? Send me on the chat. Okay, another answer. Yes, thank you. Since it's a transverse wave, that means it will oscillate up and down. So the answer is what? Is B. Okay, thank you, Tina. Next question, question number 2. A drop of water, okay, from the tap falls into the surface of the some water at constant depth, okay, at constant depth. Okay, constant depth. Water wave spreads out on the surface of the water. Which statement is it true? Which statement is true here? Question number 2. Is the water waves longitudinal or is it transverse? It's what? Transverse. Does it move, spreads out in same speed in all directions, since we are talking about same depth, okay? Or they are traveling at more quickly in one direction than the other? What you can see that the separation distance is the same, so the correct answer also is what? Is B. Good. Next question, question number 3. The drawing shows a wave which labeled distance is a wavelength. Which labeled distance is the wavelength? Yes, thank you, Salman. Thank you, Tina. Okay, now we know that A is the amplitude, and B, as you can see, C is the wavelength, and B is a half wavelength, so wavelength divided by 2. Thank you, Ali. And D is a twice what? Twice the amplitude. So we have to be careful about this. Okay, now the wavelength, it's supposed to be from crest to crest, or from trough to trough, or for complete positive, then negative pulses, okay, or negative and positive pulses. So the labeled C is the wavelength. So that's why the answer is C. Yes, thank you. Next, they sometimes give you information like this question. Water, okay, waves travel more slowly in what? In the shallow water with the ash, okay, and a person drop a stone into the pole at X. The diagram shows the first wave front, okay, of the surface on the pole, okay. Which region of the pole likely to be most shallow? In which region is most shallow? So since the wave travel this far here and this far here, okay, on this region, and the same thing for part D and B, okay, in which region is the slowest? The slowest will be more slowly. So that's, yes, correct answer. The answer is what? Is A. So A is the shallowest, okay, while what? While C is the what? Deepest, because it's fastest, okay. So the water wave here, it's what? Is deepest. And according to the 6 S's that we learned it before, okay, the S shallow, okay, that means it's slow, that means close distance, that means the wavelength is short, okay. So the answer is A. Thank you, Yasmin. Also, question number 5. Which diagram represents a straight wave front, okay, passing through a gap with a small open barrier? This is an example for what? Yeah, who can tell me? This is an example for what? Exactly. Thank you, Salman. This is an example for what? Diffraction E. Number 6, a student measure how far a cork moves up and down, okay, on a wave tank, okay, of water. Which quantity he can obtain from his measurements? He can measure what in this situation? Exactly. He can measure the amplitude of which is half. Okay, if he put the ruler horizontally like this, he can measure what? The wavelength. So he also measure only here the what? The amplitude. Frequency, he need a stopwatch to count how many what? We know that frequency, how many vibrations happens divided by time. The speed, we need distance and time. Okay. The wavelength, if it was horizontally, like this one, this is the wavelength from here to here, but the ruler is vertically. Energy cannot be measured by a ruler in this situation. Okay. Clear? Okay. Number 7. Thank you, Jasmine. Thank you, Tina. Okay. Number 7. The diagram shows 4 wave sources. Okay, source of waves. Okay, which source regenerates what longitudinal wave? Now, longitudinal wave, as you know, it's like sound, like any wave.
I think loudspeaker because of sound.
Exactly. The correct answer, man. The loudspeaker is longitudinal because this is water waves and it's transverse. Radio transmitter, it sends radio waves also, or radio waves, and lamp, it sends light. So light or radio waves or water waves are transverse. Only the loudspeaker produces sound, which is longitudinal wave. Yes, thank you. Correct. Next question, number 8. Radio waves are, yes, Salman, what do you have? Question? You raise your hand. What
diffracted.
You want to answer this question. Now, question number 8. Thank you, Salman. Radio waves are received, okay, at the house of the bottom of the hill. As you can see, the waves reaches the house, okay, caused by what? It was a plane wave, and then what? As it passed through the hill, it changes direction. It was a plane with a curve in the bottom like this. So it changes direction. What that called? This called diffraction. Diffraction. Why diffraction? It's like a gap. They're supposed to keep moving a straight line like this, but because of that, okay, there is a hill, okay, or there's a mountain, okay, the wave change its direction a little bit. That's called diffraction. That's why when you go through a tunnel or below a bridge, sometimes the radio station in your car, okay, lose signal because sometimes there is not enough diffraction to reach the transmitter or the receiver, sorry, of your car. So that's why you lose the signal. Okay. So question number 8, this is called what? Diffraction. Okay. Number 9, what do we have here? Number 9, they said that the diagram, okay, the diagram shows 4 waves drawn at the same scale. P, as you can see, 4 divisions for the longitudinal, 1 division for the amplitude. Q, 4 divisions for longitudinal, 2 divisions for the amplitude. R, 1 divisions for the amplitude, 2 divisions for wavelength. S, 2 divisions for wavelength, 2 divisions for what? Amplitude. Which statement is correct? Who can tell me which statement is correct? Thank you. Yes. Another answer. Yes. Good. Which statement is correct? The amplitude of A, B, P, okay, this one, is the same as the amplitude of what? Of R. Yes. This is 1 division and this is 1 division, so they have same amplitude. This statement is correct. If we check the others, okay, B, the amplitude of S, this one is twice, okay, number 2 division, sorry, is double the amplitude of Q. Q also, the amplitude is also 2, so it's not doubled, it's the same. So this one is not correct, the word double here. The wavelength of Q wavelength is double the wavelength of P. Look here to the Q. The wavelength here, it's what? 4 divisions. And also for P, the wavelength here, it's also what? 4 divisions. So it's not doubled, it's the same. The wavelength of wave S is the same as the wavelength as Q. This is S. This is the wavelength. It's only 2 divisions, while Q, it's 4 divisions. So it's not the same. It's half of Q. So the correct answer, as we said before, it was A. Question number 10. A swimmer is sitting on a rock at a seashore, looking at passing waves. He noticed 5 complete waves pass him in how long? In 20 seconds. So I know the number of waves and we know what? The time. So they ask about the frequency. We know that frequency equal number of vibrations or oscillations divided by time, which is 5 divided by 20. So the answer is 0.25 hertz. And the answer is what? Is A. If you flip the answer, if you write 20 divided by 5, you get 4. And you will find this answer like this, but it's not correct answer. So the correct answer is frequency, number of vibrations divided by time, which is 0.25. Good. Any questions so far? Yes, the period is the opposite of the frequency. Correct. Question number 11. Water waves change direction when they move from shallow water to deep water. What is the name given for this effect? Okay, now in shallow water, the waves are close to each other, the wavelength is short, and they have slow motion. As they go to deep region, the angle becomes bigger. This is the angle of incident here, the angle. Okay, sorry, this is the angle of incident here. Okay, between the incident, the wave, and the wavefront, as we can see here. This is a small wave. It becomes what? Bigger. The wavefront of the refracted wave bigger. Okay, and if we draw the normal like this, we can see that this is the angle of incident and this is the angle of refraction. It moves away from what? Away from the surface. So this is called what? Exactly, this is called refraction. Change the direction due to the change in the speed. Bravo. Okay. Number 12. In a ripple tank, water waves move towards a barrier with a narrow gap. Which one shows what happened after past the gap? After the wave passed the gap. Okay, in this situation, it will not continue plane wave, even like this. It will not continue plane wave with a bigger direction, okay, or bigger size of it, okay, not the amplitude. And it will not be curved in this situation also. It will diffract in this situation. So the correct answer is what? Is D. Okay, thank you, Tina. Let's move on. Number 13. A vertical stick is dipped up and down in water at P. Here we have P and this water surface, and we bring a stick and we move it in and out in the water. Okay, the water in 2 seconds. This is the time. In 2 seconds, 3 waves. This is the number of waves. 3 wave crusts are produced in the surface of the water. Which statement is correct? Distance x. This distance x is the amplitude. Actually, I'm looking about top view here. I can't see how much the wave move up and down, so I can't see the amplitude. X is what, ya shabab? It's exactly the wavelength. So that means y, the distance y is the wavelength? No, it's what? It's twice the wavelength. Bravo, twice the wavelength. Okay. Each circle represents a wavefront. Yes, each of these circles are representing what? A wavefront. The frequency of the wave is 3 hertz. No. The frequency is 3 waves, 3 vibrations divided by what? 2 seconds. So it's 1.5 hertz. So the correct answer is what? Is C in this situation. Good. Okay, thank you, Salman. Number 14. I want from all of you to send me the answer on the chat. The diagram shows a certain, a section through the a series of waves on water. Which dotted line, the position of the still water, surface when the wave passes, when there is no water waves, when there's water at rest. So which one is the correct answer? Some of you send me the answer is B. Some of you send me the answer is C. Some of you tell me that the answer is D. Actually, we know that when the water is at rest, it doesn't move. When there's waves, that means it will oscillate above and below this one. So it will move like this. So which of these lines is similar to the rest line that it's the line in the middle that I draw it? Which one of these? Exactly. Thank you, Tina. Thank you, Salman. Thank you, Omar Ali. It's B. It cannot be below the water and the water get above it. It's not tidal wave and wave vibrations. Okay. Also, it cannot be moving up without moving down. So it cannot be C. Okay. And it also cannot move down without moving up. So it cannot be B. So the rest line here, that's what B. And this is the amplitude. And also this is the amplitude. And for water waves, the amplitude not necessarily to be equal in both sides. Yes. Thank you, Yasmin. Yes. See, the water waves only vibrate up. We are supposed to, for transverse, to vibrate up and down above the equilibrium position. Tamam? Is it clear? Okay. Number 15. Welcome, Salman. Number 15. From deep water to shallow water. Which one is the correct answer? You can see that the water waves reaches the barrier without an angle, so it cannot change its direction. So C and D are not correct. But we know that in shallow water, what happened to the wavelength? What happened to the wavelength in shallow water? Yes, the wavelength decreases, exactly. So the correct answer is bravo, is B. Thank you, Tina. Thank you, Salman. Thank you, Ali. Okay, so the correct answer is B. The wavelength gets smaller. Yes, تفضل يا
Mr.
Salman.
Please repeat.
Oh, no problem. I will repeat. Now we know that the waves, okay, here they're approaching the barrier with no angle, 0 degrees. Okay, so as they pass from region to another region, they will speed up or slow down. Now we know that according to the 6 S's that we learned, that study them. Okay, in shallow water, what happened to the speed? The speed becomes slow, and the wavelength becomes short. So the wavefronts get close to each other. So the answer can be what? B, or can be what? D. But they cannot change their direction in this situation because there is no angle here. The angle is 0. There is no angle, exactly. It's not passing or reaching the barrier with an angle. Okay, all of the points of the wavefront, they reach the barrier, okay, at the same instant, so they cannot change their direction. Okay.
Okay, thank you.
You are welcome. Okay. Number 16. What's the name of this? What's the name of this? Is it diffracted? No, it's not diffracted. Thank you, Ali. Huh? Thank you, Tina. It's refracted. Why they refracted? As they go from deep region to a shallow region, there is a plastic block, okay, that make the water shallower here. Exactly. They slows down. Okay. So the correct answer is what? Is C. Correct. Thank you. Number 17. I want from you to tell me. Okay. The diagram shows a plane waves reflected from a plane surface. Okay. Which line represent a wavefront? Now, what's A? Who can tell me what's A? Write down in the chat. What's A? What's what we call it? Bravo. Another answer. Bravo. Huh? Okay. What's B? Send me on the chat. What's B? What we can call B? Excellent. Okay. Bravo. Another answer. Tamam. Okay. Good, Tina. Huh? Okay. What is C? Bravo. Good. Huh? شايفين? All of you know the answer. Okay. And D is what? Is the surface that makes the reflection, and A is the ray, show us the direction of the wave, and B is the wavelength, and our answer, the wavefront, is what? Is C. Good? Good. Next. Yasmin. Which the diagram shows a water waves in ripple tank. Which line represent a wave front here? Which one is representing a wave front? Bravo Yasmin, bravo Tina, huh? Bravo Salman. Who else? Yalla. Okay, let's go over here. Now this is the wrist line here in the middle. Okay. Here is the wrist line. Tamam. What do I want? They want A or B or C or D. Who can tell what's A? Bravo. Another answer. What's A? Excellent. It's the amplitude. B is the wave front, is what they ask for. C, as we know, it's from trough to another trough. It is the wavelength. Okay. And D, it's nothing actually. D, it's nothing. It's the surface of the water wave as it passes. Okay. So the answer is what? Is B. Good. Okay, let's move on to next question, 19. This 19 has a question similar to the question about longitudinal wave. Which of these following is, okay, longitudinal wave? Which waves are longitudinal? You can see this is light, this is microwave, it's a transverse also. This is sound wave produced by trumpet, okay, and this is here, you can see that in the center of the lake, okay, or the pond, the waves moving fast, but as they get close to the shore, the depth is shallow, so they get close to each other. So we're talking about water waves. So the correct answer, yes, thank you, Tina, and thank you, Salman, and thank you, Yasmin. The correct answer is C. It is sound. Yes, sound is longitudinal wave. Number 20. What do we have here? A navigation bow floating on the sea oscillates up and down as the wave passes. In exactly 2 minutes, we have 6 complete wavelengths past the bow. Okay, what is the frequency? Now we know that frequency equals the number of vibrations divided by time. The number of vibrations are 6 divided by 2, but we are not talking about 2 seconds. We are talking about 2 minutes here. So we have to multiply it by what? By 60. And the correct answer is what? 0.05. Thank you, Salman. So the correct answer is what? Is A. Because we are talking about 2 minutes, 120 seconds. Good. Okay. Last question here in the multiple choice questions. What do we have? The displacement distance and the displacement time graph, okay, are for water wave and a ripple tank. We have displacement distance and we have displacement time graph. What is the speed of the water wave? Now we know that speed is equal to what? Frequency multiplied by wavelength, or wavelength multiplied by frequency. It's the same thing. So now if we look here, on this graph, the distance for one wave, this is the wavelength, it's how far it is. It is 2 what? 2 centimeters. So from the graph here, we find that the wavelength is equal to what? 2, okay, which is the wavelength, lambda. But if we look here to the time for one complete wave, this is the time for one complete wave, it's the period. So the period equals 0.04. So from the period, I can find what? The frequency, which is the inverse of the period. So 1 divided by 0.04, which is what? 25, exactly, 25 hertz. And this is what? This is the frequency. So that leads us again that the velocity of these water waves are 2 centimeter multiplied by 25 hertz. So the answer, it will be what? 50 centimeter per second, which is what? Which is D. Yes, 50 centimeter per second, which is D. Go. Yes. Thank you. Yes, good.